All right, we're going to continue our discussion about functions, and we're going to get into function notation, how to read that better, and also how to use function notation to find the output algebraically. All right, how to use function notation. So first off, how do you read function notation? Well, a lot of students get very confused because they see an equation or they see some words and they don't understand what it all means. Okay, so sometimes they'll see a function written like this, and they're not really sure what is the y. Okay, or they read it and they're not really sure what is the input, what's the output. Well, here, if it says f of x is y, just so you know, the rule is f of x is y, or the output. F is the name of the function, and x is the input of the function, okay, when you have that. So whatever's in parentheses, I should say, is the input. That's what you're plugging into the equation of the function. When you have f of something, whether it be a variable or whatnot, the something is what you're plugging into the equation of the function equation. Y in terms of something, all right, y in terms of something, the y, once again, is the output. And you're putting in terms of the whatever comes after of, the something is what you're plugging in. Okay, so that of part, that something, is the input. All right, well, let's use an example. Let's go through some. So using function notation, what we have is f of x equals, now we have this equation. Generally have equations or we have numbers or something like that. And when we have that, we're saying that f of x is our function. Its entirety is the output that we're talking about. We're referring to usually the equation. In this case, our equation is right there. It is made up of, what's inside of here is the input or the placeholder for the variables. All right, it's a placeholder. It's where you plug in, the places where you plug in all the values, okay, or substitute those in. And here we have two different placeholders. So we have two different input positions. So for example, if we say this, f of 2, all right, evaluate f of 2, evaluate f of 2, well, we first have to know what is f. So that's where the equation comes in. Now, sometimes in books or when you get to higher level mathematics, they don't really give you the equation. And many times when you're in Algebra 2 or Algebra 1, they do. Here we do have an equation where we are using the independent variable, which is x cubed minus x minus 2. So how does this work? Well, if we're asked to evaluate f of 2, we look and say, okay, what is f? F is my equation, all right, or what will help me get my outputs, all right, input and output machine. So we're going to plug in 2 into each one of these placeholders. That's where we plug it in, because that's what x is. X is 2. So we have 2 cubed minus 2 minus 2, which will give us, that would be 8 minus 4, which would be 4. So what is it going to equal? F of 2 equals 4. Plug in 2, we get out 4. Input, output. Okay, input and output. If we had, for example, we change this up. Let me get rid of this. And we plugged in, for example, let's get rid of this 2 up here. Plug in a -5. Well, we plug in -5, what we would get is -5 cubed. Notice how I put parentheses around there because it's -5 cubed minus -5 minus 2. And we can simplify that, and our value would be, okay, what would that be? Negative 125 plus 5 minus 2. So we have a negative 118. Hope I did that right. All right. And that would equal 118. So f of -5, my input, when I plug in -5, I get out negative 118. That's my value. Input, output. Okay? So whatever is inside of the parentheses, that's what I plug in. I can plug in e. I plug in e, I look at my f is that equation, I plug it into the placeholders. So it'd be e cubed, parentheses around there, minus e, minus 2. I can't simplify that any farther, so that's my output. I plug in e, f of e equals e cubed minus e minus 2. I like to do this one if we have elephant. Make it a little smaller. We can even fit an elephant inside the parentheses. Yes, an elephant. If we have elephants, what will we get? Well, whatever we plug inside, that's my input. So I input an elephant, and I'm going to cube it. Minus an elephant, minus 2. And that's my answer. I can't simplify that because elephant's cubes, it's a bigger elephant minus another elephant minus a 2. I don't know what that would give me, but it's something, and that's how we work. We can even input a function into here. And this gets to really advanced algebra. I can even input functions as an input. We will talk about this later as a composition of two different values. So what we have is f of x minus 3 over x plus 2. Well, remember, whatever's inside is what I plug in to the f. This is my output, or my equation. Many times it's the equation. So what do we have? Well, my equation is there. I'm inputting this. This is my input. So what should I have? Well, x minus 3 over x plus 2, that cubed, minus quantity x minus 3 over x plus 2, minus 2. And that's it. That's my output. All right? That's what I get when I plug in this input. Sometimes you can simplify that, and you might have to simplify that. That's kind of difficult. But that's what we get. Okay? So when you have specific values, sometimes you'll be asked to evaluate this. Evaluate the function at each specific value of the independent variable and simplify. So if you want to try this, that's what we have. Ask me find g of x minus 4. G of x minus 4, well, what's g? G is here. Well, it's g of t. Oh, but this is function g. What is function g? That's function g with the t's in there. Notice our placeholders here and here. So that means here's an input and here's an input. So if I'm asking you to take function g and plug in x minus 4, I need to plug this into each one of the placeholders. Now, that's a lot of arrows there, so I apologize. Okay, but that's what we're going to do. We're going to take whatever we have for function g, that's my function, give it a name, and we're going to plug in x minus 4. So we have 2, x minus 4, that quantity squared, plus 3, all over x minus 4 squared. And that's my answer. You can simplify it, but that's what we have. We have g of x over 2. G over x over 2. Well, x over 2 is my input. Once again, I'm plugging into both the things that are inside the parentheses. This is function g. And so I have 2 of x over 2 squared plus 3 over x over 2, that quantity squared. And those are my two answers. I can simplify them if I wish, or I can leave it as. I'll simplify this one. Looks kind of a little easier. So we have 2, we have x squared over 4 plus 3 all over x squared over 4. Take that, and we have this and this will cancel to the 2. So we have x squared over 2 plus 3, all that times 4. So that will be reciprocal over x squared. All right, let's simplify a little farther. So we have 2x squared plus 12 over x squared. Okay, and that is my function. All right, that is my function. And obviously, x can equal 0. Okay, that's what we have. Even though there's a t here, okay, and this is where students sometimes get confused, even though there's a t there, t is a placeholder. That's my input, my original input. But it's a placeholder of the equation. Here's a t and here's a t. So when I put something else in parentheses, and I'm using function g, or where my output is, it's telling me, hey, I need to plug it into here, which would be that, and here, which would be that right there. And that's how you use function notation.